Hello friends, welcome to Learner's Planet. Friends, in this session we are going to discuss some difficult problems that are based on remainders and the division of very big numbers. I hope you might have attended the previous session. If not, I would suggest that do attend the session before going for this session. Okay, let's take today's problems. Now, the first problem in this session is if 351 raised to n and 352 raised to n will leave the same remainder when divided by 7, then what's the value of n? Now, let's do 351 can be written as 350 plus 1 and that is raised to n. Similarly, it can be written as 350 plus 2 raised to n. In this case, if it is divided by 7, the remainder will be 1 raised to n since 350 is multiple of 7. So in this expansion, each and every term will be multiple of 7 except 1 raised to n. So we'll be getting the remainder as 1 raised to n, and here will be getting the remainder as 2 raised to n. Now, the question says the remainder is same, that is 1 raised to n and 2 raised to n is same. So we have to find out the value of n in this case. So 1 raised to n will be 1 only. Now what can be the value of n? So if it is divided by, if 2 raised to n is divided by 7, we get the remainder as 1. Suppose I take 2, so it will be 2 square, which won't give the remainder as 1. Suppose n is 3, so 2 cube, that is 8. So if 8 is divided by 7, the remainder will be 1. So the value of n will be 3. It's very simple. Now let's take the next example. Find last digit in the expansion of 36472 raised to 123 factorial minus 34767 raised to 76 factorial. Friends, the problem looks like tedious. So let's recall the method which we used in our previous sessions when we had found the unit digit of any expansions. So in the session, I had already discussed that if 2 is raised to, or any even number is raised to any multiple of 4, the unit digit will be 6 in that case. Okay, so here 123 factorial is multiple of 4 because after maybe 3 factorial, each and every term will be multiple of 4. Okay, so 123 factorial is multiple of 4. Similarly, 76 factorial is also multiple of 4. So the unit digit in this case, just of 36472 raised to 123 factorial will be as good as 2 raised to 4, and in this case it will be as good as to 7 raised to 4 unit digit. So 2 raised to 4, the unit digit of 2 raised to 4 is 6, and 7 raised to 4 unit digit will be 1 only. So final unit digit will be 5. Okay, just have to remember that 123 factorial and 76 factorial both are multiple of 4. Okay, so in power cycle we'll be getting the 4th place. Let's take another problem. Now, what is the remainder when 4 raised to 2 raised to 3 raised to 4 is divided by 13? Friends, let's do this problem mentally. We'll start from the innermost bracket. 4 square that is 16. If 16 is divided by 13, what will be the remainder? It will be 3. That 3 raised to 3, that is 27. If 27 is divided by 13, what will be the remainder? It will be 1. That is 26 is the last number below 27, which is a multiple of 13. So we'll be getting 1 as remainder. Now that 1 raised to 4. So finally we will be getting the remainder as 1. The problem looks like tedious, but actually it is very simple. We have done the calculations mentally. So 1 will be the correct answer. Now let's see the next problem. Find the remainder when 1 raised to 97 plus 2 raised to 1997 plus the series is going up to 1996 raised to 1997. If the entire expression is divided by 1997, we have to find out the remainder. So let's begin. Don't worry by looking at the length of the problem. Okay, let's begin. Okay, say 1 raised to 1997. I just write it as it is. Then plus 2 raised to 1997. Okay, 1996 I can write it as 1997 minus 1 raised to 1997. Similarly, the previous terminology, suppose I talk about 1995, it can be written as 1997 minus 2 raised to 1997. Friends, now you'll observe we'll be getting the remainder 1 in this case, that is 1. Here we'll be getting the remainder as 2, 9, remainder from 2 raised to 1997. Here we'll be getting the remainder from minus 2 raised to 1997, and from here we'll be getting the remainder from minus 1 raised to 1997. So from left hand side we'll be getting all the remainders in positive, and from right hand side we'll be getting all the remainders as negative. Suppose here we are getting 1 and here we are getting minus 1. So both will be cancelled. Here we are getting 2 raised to 1997. Here we are getting minus 2 raised to 1997. Similarly, all the terms will be cancelled. So finally we'll be getting the remainder as 0. The problem looked like tedious, but actually it is very simple if thought carefully. Okay friends, let's take another problem. Now let's see this problem. Find remainder when 1 factorial plus 2 factorial plus 3 factorial till 100 factorial is divided by 24. Now let's begin. It's 1 factorial is 1, 2 factorial is 2, 3 factorial is 6, 4 factorial is 24, and so on. So we can see that after 24, each and every term will be multiple of 24. 24 will definitely be included, or we can say 4 factorial will definitely be included. So we are left with these 3 terms only. All the terms here will be divisible by 24 or 4 factorial. Okay, because suppose I write maybe 7 factorial. So 7 factorial means 7 into 6 into 5 into 4 into 3 into 2 into 1, and this term is actually 4 factorial. So each and every term like this will be divisible by 4 factorial. So we are left with 1 plus 2 plus 6. That is 6, 7, 8 and 1, 9. So the remainder will be 9 only. Okay friends. Now let's see this problem. If 4 raised to 44 is divided by 44, then what will be the remainder? Friends, we had discussed in our previous session that if R is remainder, if A is divided by B, if R is remainder, if A is divided by B, then CR will be remainder if CA is divided by CB. So we'll be using same funda over here. You have to just recall the concept which we have already discussed in our theory of number session. Either you can go to the session once again. Okay, so we'll be using the same funda, or again I can just make a recap over here. If A is divided by B, then R is the remainder. Then if CA is divided by CB, then CR will be the remainder. We'll be using the same funda over here. Now 4 is to 44 by 44. I can just write it 4 is to 43 into 4 upon 11 into 4. So this 4 by 4, we take it separately and we'll be solving 4 is to 43 by 11. That means we are going to find out the remainder when 4 is to 43 is divided by 11. Okay. Now let's recall a number that exists in the power of 4 and that is closer to 11. I can write 4 is to 43 as 2 is to 86. Okay. Now there is a number which is there in the power of 2 and that is closer to 11 or 11's multiple, that is number 32. and 32 is actually 2 raised to 5. So let me break 2 raised to 86 into power of 32. It's 2 raised to 85 into 2 by 11, and 2 raised to 85 is 2 raised to 5 into 17. Okay, just a moment. Now it is 32 raised to 17 into 2 by 11. Now 32 raised to 17 can be written as 33 minus 1 raised to 17 into this 2. Okay, so if this term is divided by 11, the remainder will be minus 1 raised to 17. So minus 1 raised to 17 will be minus 1 only. That minus 1 into this 2, it will be minus 2 only. So final remainder is minus 2, but the remainder cannot be negative. So finally it will be 11 minus 2, which is 9. Okay, so the final remainder, if 2 raised to 86 is divided by 11, is 9. But if as we have already discussed, if CA is divided by CB, the remainder will be CR. So in this case C is 4. So 4 raised to 44 divided by 44, the remainder will be 9 times 4, that is 36. So the problem is very simple. It looks like tedious, but but involvement of one more concept is there, and the concept is actually very simple. Okay, let's do one more problem like this. Now in this case, if 19 raised to 95 is divided by 95, then what will be the remainder? Now 19 raised to 95 by 95, it can be written as 19 raised to 95 upon 19 into 5, or we can write it's 19 raised to 94 into 19. So further, 19 raised to 94 by 5 into 19 by 19. We just keep this 19 by 19 aside, and we find the remainder if 19 raised to 94 is divided by 5. The unit digit of 19 raised to 94 will be 1. Since 9 is having even power, so then unit digit will be 1 only. So if the unit digit is 1, if you divide the number by 5, we'll be getting the remainder as 1 only. So that 1 into this 19 will be getting the final remainder as 19. I hope you are clear with the problem. As I have used the same concept, if A is divided by B, the remainder is R. Then if MA is divided by MB, the remainder will be MR. Okay, friends. Now let's see this problem. What is the remainder when 1 raised to 5 plus 2 raised to 5 plus 3 raised to 5 till 100 raised to 5 is divided by 4? Now, from even numbers, that is 2 raised to 5, 4 raised to 5, 6 raised to 5 and 100 raised to 5, we won't be getting any remainder if we divide them by 4. So we'll be getting the remainders only when the odd numbers are divided by 4. Okay, let's begin to do this. So from 1 raised to 5, I just write it 1 raised to 5 plus 3 raised to 5 plus 7 raised to 5 plus 9 raised to 5, 97 raised to 5 plus 99 raised to 5. So we'll be getting the remainders from these terms only. Now from 1 raised to 5, we'll be getting the remainder as 1. Now from 3 raised to 5, I can write it like 4 minus 1 raised to 5. I can write it this 7 raised to 5 as 8 minus 1 raised to 5. I can write 9 raised to 5 as 8 plus 1 raised to 5. Similarly, 97 raised to 5 can be written as 96 plus 1 raised to 5. 99 raised to 5 can be written as 100 minus 1 raised to 5. Of course, there will be one more term over here, that is 5 raised to 5. Just write it over here. Okay, so from this we are getting the remainder as 1. from this we are getting the remainder as minus 1. From 5 raised to 5 I'll be getting the remainder as 1. From 7 raised to 5, that is 8 minus 1 raised to 5, I'll be getting the remainder as minus 1. So finally I'll be getting half of the remainders as positive one and remaining half of the remainder as negative one. So finally all the terms or all the remainders will get cancelled and I'll be getting 0 as the remainder. I hope you find the problem easy. Now let's see this problem. Find the remainder when 2 raised to 100 plus 3 raised to 100 plus 4 raised to 100 plus 5 raised to 100 is divided by 7. Okay, let's begin to do. Here it's 2 raised to 100 plus 3 raised to 100. 4 is actually 7 minus 3. 4 can be written as 7 minus 3 raised to 100. So the remainder will be minus 3 raised to 100, and since there is an even power to minus, so further we'll be getting 3 raised to 100. Similarly 5 can be written as 7 minus 2 raised to 100. So minus 2 raised to 100, and since there is an even power to minus, so further we'll be getting 2 raised to 100. So finally 2 times 2 raised to 100 plus 3 raised to 100. Okay. Now let's find a number which is there in the power of 2 and which is closer to 7 or its multiple. Okay, so that's we can convert it to 8. So 2 raised to 100 can be written as 2 raised to 99 into 2 plus 3 raised to 100 can be written as 9 raised to 50, and this 2 is there. Now this 2 raised to 99 can be written as 8 raised to 33 into 2 plus, if 9 is divided by 7, the remainder will be minus 2. So minus 2, it is 7 plus 2 raised to 50. So the remainder will be 2 raised to 50, not negative but positive 2 raised to 50. Okay. Now similarly 8 raised to 33 can be written as 7 plus 1 raised to 33. So remainder will be 1 raised to 33. So it will be 1. So that 1 into this 2, it's 2. Similarly for 2 raised to 50, we can write it as 2 raised to 48 into 2 square. And 2 raised to 48 is actually 8 raised to 16. Now 8 raised to 16, if divided by 7, the remainder will be 1 raised to 16. So that will be 1. 1 into this 2 square, that is 4. So here we'll be getting 2 raised to 50. If it is divided by 7, the remainder will be 4. Okay. Now the final answer will be 4 plus 2, 6. 2's are 12. Now 12 is divided by 7. We'll be getting the remainder as 5. So the final answer to the problem is 5. I hope you are clear about the steps. Now in this case we have to find the remainder when 12 factorial plus 2 is divided by 13. Friends, there is a theorem called Wilson's theorem. According to the theorem, if p is a prime number, then p minus 1 factorial plus 1 is divisible by p. So here p is 13. The 13 is a prime number. So 13 minus 1 factorial, that is 12 factorial plus 1, will be definitely divisible by 13. Here we are having 12 factorial plus 2, that is 12 factorial plus 1 plus 1. So this expression is divisible by 13, so we'll be getting the remainder as 1. If you can memorize this for theorem and formula, that it would be great. The same can be applied in the other problems also. Else you can very well go for the manual method, which we have already discussed in our previous questions. Okay friends.